Students, tangent theorem. We have now studied about the tangent theorem. What is the tangent theorem? So the statement is a tangent at any point of a circle is perpendicular to the radius at the point of contact. So here, as per the statement, we draw the figure. There is a circle with center O, and there is a tangent, and that tangent means the line L, and there is a point of contact, that means the point which is the common to both circle and as well as the line. So A is the point of contact, line L is the tangent. Now see that here we write the given, that is line L is a tangent to the circle with center O at the point of contact A. Now we have to prove that the line L is perpendicular to the radius OA. Okay, so how can we prove this theorem? That is, first we assume that line L is not perpendicular to segment OA. We have to prove that the line L perpendicular to radius QA. So OA, but here we conversely assume that this, indirectly assume that the line L is not perpendicular to segment OA. That means we have to suppose segment OB is drawn perpendicular to line L. There may be some extra segment that will be, any segment that will be perpendicular to line L. So of course B is not the same at A. So that means we can say that here, now take a point C on the line L such that ABC and BA is equal to BC. So here students, if you take out that the point C on the line L, and this line L is the tangent and C point is other than the point of A. So we take the point C as a OA is BA is equal to BC students. Okay. So now we have the two triangles, and in these two triangles, that means in triangle OBC and triangle OBA, we have the first, that is segment BC is congruent to segment BA. Here students, segment BC is congruent to segment BA. Okay, and because of the construction. Now here angle OBC, students see here that angle OBC is congruent to angle OBA. Okay, OBC is congruent to angle OBA. Okay, because each angle is right angle triangle. Now here the third point is that segment OB is congruent to segment OP because it is a common side. So we have the 3 points, and due to 3 points, these are the congruent. So we can say triangle OBC is congruent to triangle OBA, and by the SAS test. So as by SAS test, we can say that OC is equal to OA, but the segment OA is a radius. As the segment OA is a radius, then OC must be radius. Okay, OC must be radius. But now here that means that line L intersect the circle in two distinct points A and C. But line L is a tangent, and so we can say it intersects the circle in only one point. If line L is a tangent, then it only intersects only one point. But here are the 2 points, that is the A and C. That means our assumption that L is not a perpendicular to radius OA is wrong, and that means we can say that line L is perpendicular to radius OA. So such a way we can prove the theorem, tangent theorem. Now converse of tangent theorem, students. So what is the statement of this theorem? A line perpendicular to a radius at its point on the circle is a tangent to the circle. Okay. Now from the statement we first draw the figure here, students. A line perpendicular to a radius and there is a circle. So we draw the first circle with radius, this radius. Okay, so M is the center and MN is the radius of the circle, and here is a tangent. There is a tangent. We draw the tangent passing through the point N, and that tangent name it as the line L, students. Okay. So now here given that we write the given M is the center of a circle, segment MN is a radius, and line L is perpendicular segment MN at N. Okay, that MN perpendicular to line L. Now here we have to prove that line L is a tangent to the circle. We have to prove that this line L is a tangent to this circle. Now how can we prove this? So let us see the proof. So here we have to construct the diagram, and as per the construction we here draw the point P, take the point P on the line L, other than the N, and anywhere in the on the point N. Now here join the segment MP, then we have triangle MNP, and that triangle MNP is a right angle triangle, students, here. So here in this right angle triangle MNP, that MP is a hypotenuse. Okay, students, this segment MP is a hypotenuse. Okay, and NP and MN are the right angle sides, and that's why we can say hypotenuse in the right angle side, the hypotenuse is the largest one side, and so that NP is greater than the segment MN. NP is greater than the segment MN. And what is the MN? MN is the radius. So segment NP is greater than the radius. And here if that we can say as segment MN is a radius and point P can't be on the circle, no other point except point N of the line L is on the circle. That any other point cannot lie on the circle which is intersect the line L. That N is the only one point touch the circle on the line, and that's why we can say line L intersect the circle in only one point N, and so line L is a tangent to the circle. Students, thank you for watching our videos. Achieve your success with us. I am sure that you will get 100% success in maths. So watch our videos continuously, regularly, like our videos, share our videos to your friends, and